Hi there, this is your favorite Done in the Math channel, and I have a limit problem for you. So let's make an observation. I'm adding powers of n, and this is the most dominant term, it's n to the n, it's the biggest term. And if I throw out all of the other terms, n to the n squared root, so it's going to be n to the 1 over n, and it would converge to 1. So I can guess that my answer is going to be 1. Okay, but we need to show it. So let's say this whole thing is equal to a. Okay, it's just for simplicity. I know that it's greater than, if I throw out all of the other terms, okay, n squared. Well, these are, even though they're small, they're positive, okay? So I can say that I can just, if I throw out these terms, it's gonna be less, okay? And this is equal to n to the 1 over n. Let's write it like this. And I know that if I take this limit, okay, for n big enough, this would go to 1. Okay, let's show it like this. Okay, this is for one part, but now I should find another bound that in the end I will say by the squeeze theorem that my limit is going to be equal to 1. Okay, so how can I do that is that I can say that 1 over n is less than n to the n. Is it correct? Yeah, 2 to the n, because x to the n is an increasing function, okay, for x is greater than 1. So I can say in the n squared root, I have 1 over n is less than n to the n. 2 over n is also less than n to the n. Okay, so it's going up to n to the n. So I have n terms, so n times n to the n, it's going to be n to the n plus 1 over n squared. So if I can show that this thing would go to 1, this thing would have the limit of 1, then I'm done, okay? But let's do one more step, okay? So I can say this thing is less than. Well, I could try to show this limit, but let's do one more step easier, okay? So I'm continuing from this point, okay? It's not equal to that. Or let's write it here. I know that n squared, n to the n plus 1, this is equal to n to the n plus 1 over n squared. And so I can find another upper bound that could be easier to deal with, okay? So I can say, so n to the x is increasing function, so if I just increase the top part, this is gonna be bigger. So I can say this is, instead of n plus 1, I can say n plus n over n squared. So this is equal to n to the 2n over n squared, which is equal to n to the 2 over n. So, well, if you also look at this part, this is n to the 1 over n. Okay, so a is actually between n to the 1 over n and n to the 2 over n. Well, I know that this thing would go to 1, but let's see if this thing would have the limit. Does it have the limit of 1? So let's show it. I'm wondering what is the limit as n goes to infinity. N to the 2 over n. So I can say, I can just take, I can say this is L, okay, and I can just take logarithm of both sides, or I could just write both sides, I could just write it like e to the power of log, but I don't want to write it longer, okay, so I could say log L would be log of this thing, and since logarithm is continuous, I can change limits and logarithms, so limit as n goes to infinity, so I'm saying log of this thing, and so it's going to be log of n to the 2 over n. So it's going to be limit n goes to infinity. So this 2 over n is going to come before. So I can say 2 log of n over n. And well, here I can actually use a trick. I used this trick before. Of course, you don't want to use L'Hopital. It's not fair to do on sequences. Actually, you can do it, but Yeah, let's do it from another way. So I know an inequality that log x is less or equal than, it's actually, yeah, less or equal than x minus 1, which is less than x. So if I can squeeze this thing, okay, so I know that log of n over n is less or equal than n over n, but it wouldn't work. So I can just multiply it and divide it by 2. And here I already have 2. I'm just going to take it before the limit, okay? And so I will show that log n over n is going to go to 0. So if I multiply it and divide it by 2, this is going to be equal to, I'm just taking this 2 to the power, okay, so it's going to be n to the 1 over 2 over n, and I also have this 2. So if I take, so now I can use the inequality and say log x is less than x. I can say this is less than x. So this is going to be n to the 1 over 2 over n, which is just 2 times 1 over n to the 1 over 2. And this thing is just going to go to, this thing is going to go to infinity, so this thing is going to go to 0. So I know that this limit is equal to 0, and I'm multiplying it by 2, it doesn't matter, so this thing is 0. So I know that log L goes to 0, okay? Log L is actually equal to 0. So I can say, if I take e to the, if I write both sides by e to the, okay, so L is going to be equal to e to the 0, which is 1. So let's do a quick recap. I showed that a to the n, a, which is the expression in my question, is greater than n to the 1 over n, and it's less than n to the 2 over n. And I already know that this limit is 1. It's quite famous limit, and I also did it in the channel. And I also showed that this thing goes to 1, okay? They both have the limits of 1, and I can say by the squeeze theorem, this thing is convergent and it goes to 1, okay? So the answer is 1, and we can finish it here.